Here is another question that someone asked and had a difficult time explaining to them. So I thought I would make a video, and I know it's not going to be the #1 best video that I've ever made, but I'll settle for somewhere in the top 200. That'll be fine. And the problem that I couldn't get across to them was the headroom height. And here you can see where we have a relatively level surface providing us with a headroom height of about 8'4". However, that is not going to be the case if we have a sloped hill, and this is a situation that they're dealing with. And if you are going to extend the patio length far enough, there's a good chance that you're going to reduce the headroom height. And the last thing you want to do is hit your head on the corner of one of these beams. And of course, the solution to this isn't that difficult. You're simply going to start at the lowest point possible, or the point that would represent the least amount of headroom. Now, I think most building codes want to see at least 7 feet, yet I have seen them go as low as 6 feet 8 inches. So raising the entire roof structure of the patio is going to provide you with one alternative. The next alternative will be to raise a separate section like we're doing here. And again, you're going to want to start with the minimum distance and work your way towards the area that will provide you with more headroom. For example, if this area is sloping in this direction, then we're going to want to start here. If we're sloping in this direction, then we're going to want to start here. And I figured that the illustrations in this model would make more sense than me trying to describe it to you. And if you're going to continue up the side of a hill, you're just simply going to start from this point here, measure down, and level across to get the post heights that you need so that no one is going to hit their head on the beams or any other part of the structure. So that's about it for the designing part of it. There is one more thing that I wanted to explain, and that would be the fact that sometimes we're going to be able to reduce the amount of posts that we use in a project like this and concrete footings if we use a construction method like this. And all we have here is a post that's going all the way up to support this beam here, and we're going to use a inverted hanger or a concealed hanger along with a piece of hardware that's often referred to as an end column cap to support the post above. And of course, this is what the hanger would look like below. And for those of you who are not familiar with my channel, keep in mind that this is just information you might be able to use. However, you will need to check with a structural engineer to verify whether or not it can be used on your project. And of course, another method would be to use the same connection up here, except we're going to get rid of the hanger and use a 2x4 to support the weight from the other beam. And a method like this might require 16 D-nails staggered 16 inches on center. However, if you are looking for something a little stronger, you can simply use a different post-based connector and a larger post, and then center everything in the footing. So for example, here we have a 4x6, here we have a 4x4, and make sure that you have the post-based connector turned in the right direction. That will always be helpful when you're building something like this. And if you can find a post to beam connector, great. If not, you can use a strap to connect the beams, and that would be the upper beam and the lower beam. And of course, we have cut a notch into the post. And for something like this, if we cut it in 2 inches or less, in between 2 inches and 1.5 inches, I believe 1.5 inches is the minimum support for a beam, then we're still going to end up with a 4x4 post or a distance of 3.5 inches after we've cut the notch to support the upper post. And hopefully by now the individual has a pretty good idea, and you, about how something like this can be built. In this video, I am going to provide you with what might seem to be common sense to some people, and an easy method to figure out how to build concrete slabs so that you don't have to cut very many brick, or to where your bricks line up perfectly with the other bricks. And of course, this won't matter whether you're running them in this direction or in this direction here. And that will become visible in our first example here, where we have the bricks running in this direction on this side. And when we come up to the edge of the patio, if we haven't figured out the length of it, then you're either going to have to cut the last brick or take these bricks and space them out a little bit to where they will line up with the edge of the concrete. Now, this isn't going to be too difficult. If you only have about an inch or two and you didn't figure the concrete slab, all you need to do is space these a little further apart. So if I have a 1/2 inch gap in between them, I might need to put a 5/8 of an inch gap in between the next 6 or 7 of them so that I can increase the spacing and move each one of these bricks incrementally a little bit further until this one here lines up with the edge. So this won't be the end of the world and probably won't be noticeable by most people. However, there's no reason for you to let that happen because you're going to figure out your concrete patio to where it lines up with the edge of the brick perfectly. And like I said, I understand this might be common sense to some or simple math, but to others it's not. So let's go ahead and take a look at the next problem you're going to face if you run the bricks in this direction without taking the time to figure out the length of your patio slabs going this way. And as you can see here, you would have to cut this brick here, and these bricks here are not lining up with the brick on the end. And this isn't going to be a big deal, or should I say might not be a big deal to most of us, but if we want these bricks to line up, then again, we're just going to need to do some simple math. Now, another thing I need to point out is that you can have the bricks tight up against the concrete slab, or you can have a gap in between the brick and the concrete. And I would recommend that you have the gap there and then fill it with the same mortar you're going to use for the edges. So for example, we have a 1/2 inch gap here, we would have a 1/2 inch gap here. And this is going to make a big difference for the bricks you install in this direction. Because if your bricks are 8 inches long and you leave an 8-inch space, and let's just say that it's 7 7/8 of an inch, then now you're going to be cutting your bricks again. However, this might not be a big deal because if you wanted the bricks around the perimeter to be tight, that would be fine. Just don't take the chance here. Maybe make it a 1/4 of an inch wider or even an 1/8 of an inch wider. But trust me on this one, you do not want to form your slabs, pour the concrete, and have the concrete push your forms over a little bit. And this might just require you to provide some additional reinforcement, maybe some more blocks, space 16 inches on center or something like that in between your forms. But again, I have to point that out. It's my job to prevent things from happening that have happened to others in the past, including myself. So in order to make all of this work out, all we need to do is figure out the length of the bricks running in both directions with the grout line or the line that we're going to fill with mortar when the bricks are installed around the perimeter and in between your patio slabs. However, before we do that, I went ahead and changed the slab so that we have a grout line in between everywhere we will be installing bricks around our concrete patio. But again, you can do it either way. This just seems to be a little bit easier. And of course, you can do this in a few different ways. I've done it before to where I've had rebar run through the concrete slabs and connect the two together. And I've also built the concrete slabs to where I could just fill this up with concrete or mortar and then set my bricks. But I won't be going over that in this video. This video was just meant to provide you with information on how to figure the length of the concrete slab so that you don't have to cut any bricks or cut the least amount possible while building your patio. And as always in our computer drawings, everything is perfectly straight and lines up perfectly, like this corner here. So let's go ahead and pan out here and get to the math portion of the video. So the first thing we're going to do is figure out the length of the bricks running in either direction or in the direction we're going to need that measurement for, along with the spacing in between the bricks. And in our example here, we are going to have 3 5/8 of an inch wide bricks and a 1/2 inch grout line, providing us with a 4 1/8 inch measurement from one side of the brick to the other side of the brick. And of course, we can just simply use that calculation to figure out the point of the concrete slab from this point to this point here. And basically what we have are 30 bricks going all the way to the end, and we will simply subtract the last brick. However, keep in mind that if we use 4 1/8 inches, it's going to bring us to here. So we're going to need to subtract a 1/2 inch so that this brick here lines up with the edge of the concrete slab if you're going to use the grout line. If not, then you won't need to worry about it, because the patio slab will need to come all the way out to here. So hopefully that makes sense there. And you will basically do the same to the other side. And let's not forget that these are only measurements I'm providing. You can have as many bricks in between your patio slabs as you want to, or even fewer bricks. But you're going to have to use the bricks, or the size of the brick and the size of the grout line, to determine the width of the concrete slab. And if you're off a 1/2 of an inch, you could end up with a problem. So whatever you do, don't let this last 1/2 of an inch mess you up. And if all of the stuff I mentioned makes sense, then you can stop watching the video. If not, let's go ahead and break out the calculator and do some simple math to figure out whether or not these measurements are correct. So let's start with the first one here. We had 29 bricks, and we want to multiply it by 4 1/8.125 equals 119.625. And if you remember, we needed to subtract a 1/2 inch. So if I need to subtract 0.5, that gives us 119 1/8, or 9 foot 11 1/8 inches, or about 7/8 of an inch less than 10 feet, and 120 inches is 10 feet. Now let's go ahead and clear it for the next one, where we had 11 bricks that were 8 inches long, times 8 equals, and I'm going to do this a little different. I'm just going to multiply the amount of grout lines that were in between each one of those bricks, or 5 inches, bringing us to 93 inches, or 7 foot 9 inches. Now let's just go ahead and subtract 84 inches from this, and 84 inches is 7 feet, to double check our measurements for our patio slab. You've always got to double check these measurements. And the last measurement we will need to check will be this one here. Won't be too difficult. We have an 8-inch brick with a 1/2 inch grout line on each side, equaling 9 inches. And even though there are probably plenty of more things I could talk about when it comes to this right here, I am going to end the video right here. In this video, I will try to provide you with some reasons why or why not you might not be able to build a deck over a concrete patio slab. And of course, the biggest problem here would be the concrete footings needed for the posts that are going to be holding up the wood deck. So let's go ahead and get rid of the stairs and build our deck anyway, and take a look at how I would do it if I was going to do something like this. And that would be to provide some type of raised concrete footings. And of course, that can be done a few ways, and I will provide you with that here in a little bit. And there's no reason why you need to remove the concrete patio slab. And I've even built brand new decks with concrete patio slabs under them so that people could clean them a little easier. So let's just say you had a 12-foot deck and a garden hose or a blower, and you wanted to clean the deck. You could just simply blow all of the stuff from one side to the other side. So keep that in mind, and of course that will depend upon the design of the deck. So let's go ahead and take a look at what the building department is going to require. and that will be a concrete footing. However, I won't be able to provide you with the exact dimensions because that might require a structural engineer, but I can tell you that I built plenty of these with 1 foot by 1 foot by 1 foot footings. So that would be a 1 foot square by 1 foot this way, except the 1 foot is going to need to go below the top of the soil. Or in areas with frost lines, you're going to need to go 12 inches below the frost line. And again, you might need to check with your local building department for more information about that. So not too difficult. You're simply going to create a hole that you're going to be able to fill with concrete for your concrete footings. Now here's the reason why most of you are probably watching this video, and that's to find out if you can just simply attach some type of a post base bracket to the top of the concrete patio slab, and then simply drill a hole into it and use some type of a anchor fastener. And the answer to that question is probably not. Even though I've seen this done before, and I've been to houses where it has been done and I didn't see any problems with it. So I will leave it at that. If you are going to do something like this to support your deck, then you might not ever have any problem structurally with it. And if you were paying attention, I used the word might. Maybe not, but you could also have problems with this, especially when you go to sell your house and there are no building permits to be found for your deck. And that's probably going to lead the building inspector to wonder if there are any concrete footings to support your deck. Next up, let's take a look at a few more options for the concrete footings. And one of those would be to leave the concrete slab as it is, but dig underneath the existing concrete slab so that you have enough room for your new footings. Another option would be to saw cut the concrete slab so that you can dig your holes for the concrete footings. And the last option would be to get a sledgehammer or a jackhammer and simply just break a section of the corner off so that you can pour your concrete footings. And this option might be eliminated depending upon how difficult it is to dig around your soil or underneath the concrete slab. And of course, whether you're going to be able to get to it from 2 sides or from 1 side like this over here. And you could always dig this out a little further so that you have access to get the dirt out from underneath here, and then use some type of a form board to prevent the concrete from spilling over into the hole or into an area where you're really not going to need any concrete. Now this idea might not work for everyone because you could break a big section of the slab off and that might require you to pour additional concrete. So don't shoot the messenger. I'm just kind of throwing this out there as another alternative. And of course, the square hole here, depending upon the location of where the footing is going to be located. For example, in this situation here, it's not located near the edge. Therefore, you wouldn't want to just take a sledgehammer and just beat a big section of the patio slab out. However, I will leave that up to you because it's going to provide you with another option, whether you rent or use a concrete saw or a sledgehammer. And of course, by doing this, you're going to be able to use the hardware that sets in the concrete. And this is going to provide you with a better structural connection. And it's always going to be good to make sure that the hardware is up at least 1/4 of an inch above the concrete slab. And in a situation like this, we removed enough of the concrete so it would be easier to dig. However, on the other side, we didn't. We just removed enough so that we could pour our footing to support the post. And the last suggestion I would like to make is one that I have already made, and that would be to create some type of a raised footing. And some building codes are going to require you to have at least 6 inches here. And that brings us to the end of the video. If you found this information helpful, make sure you let us know by hitting the thumbs up button. And don't forget to check with your local building department to get permits for any modifications to your home. In this video, I am going to try and provide you with a couple of methods that can be used to avoid blocking foundation vents when you actually build something that blocks them. So the For those of you who don't know what a foundation vent does or a crawl space vent, it actually allows air to enter into a crawl space area under your floor and basically remove moisture. Now, in some cases, it might be adding moisture, but again, that would depend upon where you live, and you would need to get more information on that from your local building authorities. Remember, people watch these videos all over the world, and the ideas that I have in these videos might not work in your particular area. Now let's go ahead and build our porch or our patio, raised deck, whatever you want to call it. Whatever it is, it's blocking off the foundation vents now. We can see that, and creating a problem for the air circulation. Here's the most common method used. You would simply notch out a hole in the slab. And of course, I'm not talking about notching it out after you pour it, of course. That would be a nightmare. You would need to actually form around it so that when you pour the slab, you would have an access hole or an area where air could vent out of the crawl space vent instead of blocking it off. Now, here's something you could do, but of course here, what do we have? About an inch. This isn't going to be the best method for most foundation vents unless you could create some type of an area that is going to be strong enough to prevent it from collapsing. But you could always come out of the side. And, you know, if you have something like this and you're thinking, now, wait a minute, you know, this could be a trip hazard, you're right. You might need to put some type of a screen or something on top of this. But the thing you're not going to want to do is block it off. And I see that, you know, this is probably one of the biggest problems in construction is somebody builds something like this and they know what's going on. They sell their house and then someone else comes on and goes, you know, wait a minute, I don't want to look at that. I'm going to fill it up with concrete. I'm going to block it off with wood, something like that, and it defeats the purpose. So these videos can be helpful. It's another reason why I suggest watching a lot of our videos is to figure out or to get a better idea of problems you could eliminate yourself with that type of thinking. You know, hey, wait, I don't need that when you really do. Now, you could always make the porch a little shorter, a little smaller, but of course that would be up to you to avoid covering some of these vents. Something else I did here on a room addition that I built one time, the homeowner had an existing crawl space area with floor framing, but they didn't want the room addition to have a wood floor. They wanted it to be concrete, so I actually had to vent out or used a couple of pipes. Here I have one, but I actually used two pipes and had them come into a large screened area to prevent the bugs from coming in. And that's actually what the screening is for, is to prevent insects and creatures from coming into these areas, but allow the air to flow through. If you don't like the pipe idea, you could always create some type of a tunnel in there. Now, there is something I didn't mention with the tunnel, the pipes, or this area over here. Make sure that the pipes and everything is sloping out. Any water that or moisture that gets in here, you do not want it sloping back into the house. So make sure that the tunnel is actually sloping towards the front. And I have drainage. I've got some slope in this already. You know, what do you need to slope it? About 1/4 of an inch? That would be fine. But of course, if it's sloping the other way, any water would get in there and drain towards the wood framing, and that's not going to be good. Even if it's level, that could be a problem. And then, of course, cover it with a foundation vent. But you still could have the same problem here. You've got to make sure that if you do something like this, that the top of this won't cave in, and it's actually going to be strong enough to support the weight, any weight that it would need to support. Now, another idea would be to simply add another foundation vent near the one that you have removed, or even you could even do this by putting another foundation vent on the other side. Now, with that in mind, you're probably thinking, well, this area is not going to get a lot of ventilation. Well, it's It's set up for cross ventilation. So if I added another vent here and another vent here, I'm still going to get air coming through these vents, or air that would be going from the front to the back or the side to the side, basically. So this is a follow-up video to a video I made yesterday where I stated that this might be a good way to prevent blocking off a foundation vent if you were going to pour some type of a patio or concrete deck instead of covering up the vents, which is what most people do. Actually, if they are going to pour a concrete foundation, covering the vents up is the most popular method. This is the second method here that I've seen used a lot, but an individual pointed out yesterday that if you do something like this and water goes in here, it's going to be trapped and it's not going to have anywhere to go except into the foundation, and that's going to make things worse than better. So I would suggest putting some type of a drain pipe at the bottom of the notch or the pocket here, and then draining it out safely to the side of the deck. And of course, that's just going to require a, maybe a 2-inch pipe here. I don't recommend putting a small pipe in there. Don't use like a 1-inch drain. Make sure that you have something that's 1.5 inches or larger. And the reason why I'm saying that is you could end up with debris building up in these areas if it's not maintained. And the debris in a larger pipe is going to come out a little easier, I should say most of the time, than in a smaller one. Now let's go ahead and take a look at my other idea. And this is common. I see this used a lot in basement windows, where you have a window that's below grade and it needs to have some type of a well around it. Usually it's made out of corrugated metal. But in this case here, you would simply just form around this, pour the concrete, pop the forms out, and then you'd end up with a slot that you could fill with gravel that could be used for water to drain down into the ground. Now, could this create problems? Yeah, if you're going to have a little bit of water, you live in an area where it doesn't rain very much, this might be okay. If you live in an area where it rains a lot, you're going to have to use some type of a drainage pipe or a different system. Now, I also mentioned putting some type of a protective barrier on the floor instead of having an open hole. And something like this, you could just purchase a pre-made grate. And these are drainage grates. You could purchase something like this that would fit into a notch, that would sit into some type of a notch that would be formed into the concrete floor. And you're going to need to be able to remove this grate. I wouldn't have something that's going to be there permanent, because debris is going to fall in here and eventually it's going to create a big problem for the drainage area if it's not cleaned out. So here we can see the gravel. It's lower, again, at least 1.5 inches lower than the top of the foundation or the footing out here. And again, remember, these are only methods or only suggestions. I appreciate the individual pointing out the problem, because that actually could have been a big problem.